else get to see their test. But I'm gonna give them at least one more day. That way I'm not giving away test scores before they actually have to go take it.
So will they not be in the Monday?
No, that way you can at least get a week to retake it. So they're not gonna be on student trip. That's another reason why math helps too. Like they're waiting until Monday, so you can take a week if you want to redo it. So, if you want to know your score, you can email me over the weekend. I'll let you know what your score is, but I'm not going to enter until Monday. So they're not in the grade, so they're not in midterm. Okay, does that make sense? Okay, but I do want to go over them. I do like to hand them out early, but I got too many people I have to take it for geometry. I can't release the scores yet or walk through what the answers are. So, all right. Apologies, I like to go through them now. All right, we will do that on Monday, and you'll get to see it in hand. You get to see what you missed, and get a week to retake if you want to retake. And it doesn't matter what the score is for retakes. You get better than that. Okay, now, today, what we're doing, we're just going to intro section 1.6. Intro. It's a light introduction. I think I got maybe 5 slides I'm going to go through, maybe 5, 6, something like that. It's really short, sweet, simple, to the point. We're done when we're done. Like, that's how it works. Because it's a Friday, we're not getting the homework, nothing like that. Okay, all right. Get the idea? Yep. Nice and easy. Nice and easy to the point. All right. So, now, what we're talking about today, we're talking about polygons, right? So if you don't know what a polygon is what most people think of geometry. They think of shapes. They want to know properties. Like, when are we going to get to that? Well, that's this section. This is where we introduce the names. We're not going through all the names, just a select few today. And so that's what this first section is, section 1.6. Now, we are technically in chapter 2. I just put this section from the first chapter in it because it makes more sense in this chapter. So, because we start talking about shapes and properties and stuff. So, all right, now, the polygons themselves, what we need to go through first is like what the definition is. That's what you need to know. So that you understand like what I'm discussing. Now, the book has the worst definition I've ever seen. Here it is. Polygon is composed of many angles. End quote. That was the definition. That's the worst definition I've ever read. I still don't, to this point, if I read that definition, wouldn't know what to draw. It's just composed of many angles. End quotes. Okay, so, other than the book failing to tell you what the basic definition is, I went through all my other geometry books out of the last 15 years I taught, and kind of picked out, like, what are the major bullets you need to know so that you can draw it and understand it, like, without a doubt. So here's like the main bullets you should know. And your book does not say. Number 1, when you draw a polygon, you have to use coplanar segments. Okay, what that means is using some vocab words from the last chapter. Obviously segments are sticks that have endpoints, right? They have 2 dots, they have the stick that connects them. But they also have to be coplanar. That was literally a vocab word we had in the last chapter. Coplanar means they're on the same flat surface. So, if you think about it, a polygon is straight walls, right, segments, that are on one flat surface. You can connect them. Does that make a little more sense? So now you're getting this image in your head. It's starting to form a little bit. Straight walls connecting on the same flat surface. Now, there's more stipulations when you draw these flat walls, these straight lines, these segments, right? Number 1, the segments have to intersect 2 or more others. So if I gave you a segment, I'm going to draw this. So if I gave you a segment, here's my line segment, right? Straight stick with endpoints. And I said it had to be connected to 2 or more other ones. This has to be connected to 2 or more others. What is the bare minimum shape I need to draw? Say it. Triangle, right? A triangle has one segment, it's connected to 2 other segments. You can see right there in front of you. Each segment is connected to 2 others. Does that make sense? That's the minimum. It has to start with 2 other walls or more. But yeah, you're right. Triangle is the first type of polygon, the names that we need to learn. Most people know what triangles are, but you don't know that there's 7 types of them. That's what I'm betting. So we're going to go through those today. We're going to intro them, I should say. Not go through properties, just the definitions. Okay, make sense? Rule number 2, when you draw the segments, right, they have to meet at quote-unquote endpoints. So when they're actually intersecting, right, when they're touching each other, that's an intersection, right, when they meet at a common point, right, they're sharing a point. When you have things that are crossing or intersecting, they have to meet at endpoints. So this is what they're trying to define. You can't do this. I always have somebody that tries to draw this picture. I pick a couple endpoints, and then they try to draw straight lines that connect them. So what if I did this? Do you agree that's a segment?
Yes.
I'm going to draw another segment. I'm going to draw another segment. I'm going to draw another segment. That failed. It failed. That one. That's not a, so that green shape here, this shape, is not a polygon. Because they didn't cross at just the endpoints. They intersected here. You can't have them cross there. They can't overlap each other. The walls can't touch. Now, if you want to be, you know, that person that goes, well, Ward, what if I just put a dot there? What if I did this and put that as an endpoint? So now there's like 6 walls. It will fail my next rule. So you can't just put a dot in the middle and say that's an endpoint, because the next rule, no segment you draw can be in a straight line with another one. No segments with common endpoints can be collinear in a straight line. Do you agree that these 2 walls were literally in a straight line 2 seconds ago? That fails. You can't do that. You can't have segments that are in straight lines. There has to be a flex in the road, or, duh, many angles. Go back to their dumb definition. So, now we're starting to get more specifics, right? We're starting to get these ideas of how do you draw it. Now, do you notice in rule number 2, I put endpoints in quotes, air quotes. There's a better word that the book uses, a new vocab word. Instead of just intersecting at an endpoint, right, at one of the dots, we have a name for that dot. It's called a vertex. A vertex, it's a point of intersection. That's a better word. I like that word, vertex. Now, if you want to go plural, vertex is one, right? One endpoint is called a vertex. If you want to go multiple endpoints, it's called a vertice. So vertices, plural. Vertices, plural, multiple endpoints on a drawing. Okay, questions with the endpoint idea or vertices? Vertex. All right, last word here, the names of the walls, the segments. I keep using segments over and over and over, right? You've seen it throughout this whole thing. There's a better word instead of calling the walls segments. They're also called edges. The sides of the picture are called edges of the polygon. That's a vocab word, or quote unquote the segments. I didn't want to put air quotes around segments because I would have had too many air quotes through this whole thing, and you've been like, where do I keep putting segments in air quotes? It's literally in every definition. The edges of the polygon, the walls, the sides. So there's 2 major parts, vertices and edges. All right, questions with the better definition. Now, if I explain that definition to you, now you can start drawing more specifically. Instead of just saying, oh, the shape's made of many angles. That doesn't make any sense. Okay, now, you're probably still thinking, Ward, I still need to see it. What are the different names? Like we talked about triangle, but what are the different ones? We'll get to those here in a minute. Now, when we start drawing polygons, there's 2 types of drawings you will have when you look in your textbook. Number 1, the first type of drawing, which is 99% of the drawings in your textbook. They're called convex polygons. Now I'm going to draw a picture of a convex polygon because you need to see it. Now ignore like what the shape's name is. Just look at the way I draw it. Convex. This is how I'm drawing. Ignore what the name of the shape is because you probably know the names. But it's how I draw it. Okay, this shape is convex. It's a big fluffy pillow. It's very open on the inside. Right? That's convex. 99% of the pictures in your book are convex. Now, I am obligated by the state to tell you the book definition of it, what every textbook will have for convex. Here's the nonsense crap that they want you to know. No line containing the side of the polygon contains a point on the interior. That's the dumbest definition ever, too. All right. What it means, if you're trying to interpret that nonsense, they're trying to tell you that if you were to pick 2 points on the inside of this picture, my big fluffy pillow, pick 2 points on the inside, any 2 points you want. You agree those are on the inside, the interior. Connect them with a straight line, a segment. Did my segment stay inside the picture? That's convex. Now you think, okay, all right, that's well, what would be the other situation? Like, how could that be different? Okay, so the other shape is called concave, right? Concave or non-convex. Concave, I'm going to draw the same type of picture. So if you actually know what the name of the shape is, it's called the Pentagon, 5 walls. I'm going to draw another pentagon, another 5-sided figure, but I'm going to draw it differently. So it's concave instead. So here's your concave picture. 1, 2, 3, 4, 5. That's 5 walls. That is a polygon. I don't have things in straight lines. I don't have things crossing over each other. That is a polygon by definition. I use segments. There are immediate endpoints. Now, do you agree that that picture definitely looks different than the first one? Mm-hmm. It's not a big fluffy pillow anymore. It's got a dent in it. It literally has a cavity, quote unquote cavity, right? Got concavities. Well, when I follow that same stupid book definition, pick any 2 interior points. I'm going to pick these 2 dots. You agree those are on the inside of my picture? They're literally interior, right? They're on the inside. Draw a straight line that connects them. What happened to that line? Went outside the picture. That's what makes it concave. Now that's what the book describes, right? A line containing the side of a polygon contains points on the interior, blah, 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 blah. Whatever. Here's my easiest way to identify. Does it look like a big fluffy pillow, very open on the inside, or does it have a cavity, a cave, a mouth? Does it look like Pac-Man? That's a concave picture. It literally has a cavity. A cavity in your tooth is a dent in your tooth where the enamel is being eroded away, right? It's got a cavity. Do we see the differences? No. 99% of the pictures in your book are convex. There's a few pictures they'll show you that are concave. But the problem is why they don't show you a lot of concave pictures. Number one, it's very unpleasant to look at. Right? Most people don't like that. It's unnerving to see that. But the other thing is, like, all the properties in geometry are based on convex pictures. Almost all the properties we have are based on convex. So that's why you see just those pictures all the time. Okay, questions about the 2 shapes? Now I'll add some more stuff to this when we start looking on the line. Like I have how to explain like this drawing, like what I did. I drew a line, connect the 2 points. Is it in the inside or is it in the outside? I tried to put some extra stuff in case you're reading about it from online. Okay, questions at all about my 2 shapes? I'll go back to those 2 words if you want. You don't need this. This will be online if you want it. It just explains what I just did. Okay, are we good? Okay, I'm moving to the next slide. Does anyone still need this slide? Moving on. It'll be online. I'll post it tonight. I can't post yesterday's video because I might have accidentally showed pictures of the test and people still have to take it, so I can't post it yet. So, that slideshow from the whole time. Okay, polygons. Now, what we need to talk about now is the names. This is what everyone wants to know. When they walked into geometry, they thought they were doing this day 1. We wait till, like, literally the midterm. Okay. The names of the shapes. So what was the first shape we talked about earlier?
Triangle.
Triangle, boom. Triangle is the first shape. It is the main drawing that most people think of when they get to geometry class. Okay? There is 7 types of triangles. 7. You can probably think of 1 or 2, but not 7. Okay, maybe 3. There's a lot. We're going to get to those words today. The goal is not to like overdo you and overcram you with properties. It's just to show you the definition, right? A triangle has 3 sides, has 3 angles, triangles, right? All right, does that make sense? We'll get to those names here in a minute. Now let's keep going through the other names. If I went to a 4-sided figure, not a 3-sided, but a 4-sided, what do you think the name's called? Not a square, not a rectangle.
Quadrangle.
Ah, quadrilateral. Okay, quadrilateral is the Latin word for 4. Most people think of a rectangle or a square or like those other shapes that are common. Those are types of quads. That's what most people don't know. Quad is literally the Latin word for 4. Like a quad ATV has 4 wheels. Quads, right? This is quadrilateral. Laterals are literally the Latin word for sides or edges. 4 sides, 4 laterals, right? So here's a 4-sided figure, random 4-sided figure. That does look like a box. It does look like a rectangle. I trust me, it's not. These angles are not perfect. I just kind of drew it up there as fast as I could. Okay, do we understand what a quad is? 4-sided. Now, we'll get to the specific names. Like, everyone wants to know what a square is and a rectangle. Like, we'll get there. That's Monday's stuff. We'll get to those. Goal today is triangles. Well, that's what I want to get to. All right, next one. 5-sided. I don't know what a 5-sided picture looks like. I even said it earlier. Pentagon. Yeah, Pentagon is 5-sided. Here's the Pentagon building in Virginia, the intelligence agency building. It was literally attacked on 9/11. Yep. The 4th plane, the 3rd plane crashed into it. Crashed into the side, like over here. Now, this is an aerial view of the building. The building's massive. It doesn't show you a sense of scale. There is a courtyard in the middle that is literally a Pentagon as well. The building is designed to be very symmetrical on the inside, so if you have never worked there before and you walked in, you would get lost very, very quickly, because there's no markings on the walls. Everything's very sterile and symmetrical, so you really have to know your way around the building to know where you need to be going. As they do that on purpose in case of an attack. But yeah, all the central intelligence agencies work in there. So, all right, that's a Pentagon building, right? 5 walls, 5 outside walls. Hexagon is 6. How do I remember that? It literally has an X in it, like the number 6. Hexagon 6, right? Hexagon looks like honeycomb. Let me zoom out, you can't even see that. Okay. Here's a hexagon. 6-sided honeycomb is a hexagon. That is the second most structurally sound object that we have in geometry. Like, it can support a lot of weight. Bees, yeah, triangle's number 1. The hexagon, that's why bees use it. It can support a lot of weight. It's easy to use. I think Reebok, the shoe company, the clothing company, has a patent on honeycomb-based shoe soles. That's what they use to hold up the structure of the sole, because it supports a lot of weight. But triangle's number 1. Triangle holds a lot of weight. That's why most bridges, when you look at the design of a bridge, there's lots of triangles connected to each other, because it supports tons of weight. Hexagon is the next one. I think protein crystals in science class are based in honeycomb shape proteins. Anyway, moving on. Heptagon or septagon. Heptagon or septagon is, there's 2 words. It's Latin versus Roman. They're interchangeable. In fact, if you start typing in your Chromebook and you type in one, it might autocorrect to the other one. And if you type the other one, it will autocorrect to the other one. It's just mind-numbing about why they do it. But it's got 2 words. I'll probably use heptagon the most. You'll probably see that on the test or quiz for vocab. Heptagon, 7-sided. I don't have a picture of a 7-sided. They don't really happen in nature a lot. I mean, you can have a 7-sided building. I mean, imagine you had a house, 4 walls, and then you just made an addition to it. You had extra couple walls for a new room, 7-sided walls, or 7-sided figure, that type of thing. All right, but yeah, so if you want to draw like a random 7-sided figure, you can do that. But that's a heptagon or septagon. Next one, 8-sided octagon. Octa is literally the Latin word for 8. There's a doctor quick here. Oh, okay, there we go. Octagon is 8. Most people think of like an octagon, they think of a stop sign. Stop sign is literally 8 walls. Right? What most people know is like the DOT, the Department of Transportation, they use these polygons as their default signs. So an octagon is most iconic, most people know it. Warning signs are always in triangle forms. Informational signs are quads, or quadrilaterals are informational signs. It's probably the hardest part of like the driver's test that you take, or permits test that you take when you first get your permit. They give you all the signs, they take all the words off of them, and you're supposed to know what they look like. It's like the hardest part of the test because you're too young to know what those signs are because you haven't experienced them enough. Like when I see a stop sign, most people know the stop sign. You don't even have to look at the words, you just know it's a stop sign, right? But no one can tell me what a do not enter sign looks like. It's just not a sign that you recognize. You don't see it every day. It's used in only a couple places. So it's like that's the hardest part I thought of the test. You really have to study the shapes and the signs. But octagon, 8-sided, right? Most people have octagon and hexagon, like they always switch these two. Hex is 6, stop sign is 8. Just count the walls. Nine-gon, a 9-sided polygon. I don't like the word nine-gon, that's the one your book has. It's called a nonagon. Nonagon. I actually really like the word. It's probably my favorite word that they have of all. Nonagon. That is a 9-sided polygon. The book just says nine-gon. That's fine, but I want nonagon on my test. I'll have nonagon on there. So you just know it's one of the vocab words. Nonagon 9. 10. Latin word for 10 or metric word for 10? Decagon. That's a Latin word for 10. Deca literally is the metric word for 10. 10-sided out, again, I don't have a picture of it, but 10-sided. These are usually the ones that most people kind of learn like in elementary days. Maybe. Maybe not all of them, but you learned a couple. There is 2 more that I want you to know. There's the 11-sided polygon, which they call 11gon. There's a better word. It's called a hendecagon. Hen is literally the Latin word for one, like one more than. So hendecagon, one more than a decagon, one more than 10. So that's a hendecagon. That one for sure is on my next test, I know for sure. I just put decagon to the vocab list. I know that. There's your hint already for the next test in like 4 weeks. And then dodecagon is 12. Do is literally the second word past decagon, right? 2 more than a decagon. After that, they don't call it a tridecagon or anything like that. They just go 13gon, 14gon, 15gon, 16gon, all the way to 100gon, 1000gon. You can call it whatever you want. But up through these up through 12, they have names. After that, they don't.
Well, a lot of them do, because people don't know.
Yeah. So, okay. Does this make sense? The ones I'm going to test you on. Okay. I want you to get familiar with those. Kind of look at them. Now, obviously, throughout the year, we're going to learn properties about these shapes. Like each chapter kind of focuses on a different shape. We probably won't spend a lot of time past Pentagon. We just don't. There might be shapes in the book, but most of the properties we learn are about triangles, quads, maybe a pentagon here and there. But most of the pictures we deal with are triangles and quads. The problem is most people don't know there's different types of triangles. There's different types of quads. There's a lot of them. In fact, on a quad, there's 7 or 8 different types of quads. Most people know rectangle and square, but they don't know there's others. So yeah, so there's others. So we're going to talk about those today. Well, at least intro. I won't go through all of them. Okay, let's get to triangles. Are we ready to go? Okay, triangles. This is like, I'm only going to do, I think we got like 4 more slides maybe. I'm almost done. Not even. I don't even think there's 4. All right, so we're going to talk about the triangle first. So classify by the number of sides. Well, obviously when we talk about a triangle, it's literally the root word there is tri, meaning 3, like a tricycle has 3 wheels, right? 3, so there's 3 sides, 3 edges, and 3 vertices, 3 angles, right? That's the idea. 3 edges, 3 vertices. So, 3s, right? Now this is just a generic triangle I could come up with, but here's the weird part. Most people know triangle. They don't know that there's 7 words you can use to describe a triangle. 7. They just know maybe a few. So my goal today is to show you the words you need to know. Because when I see this picture, when I see this triangle, every triangle, even though I told you there's 7 words, every triangle you have a picture of has 2 names automatically. 2 names go with that picture, other than just calling it a triangle. That's the thing you need to understand, that we can pull from 2 separate categories. The first category, when I look at that triangle, I can name it by its sides. Side lengths. So if I took a ruler and measured the walls, there's a name for that. Second way to describe it is by its angles. So this is where your protractor comes in. You will need a protractor eventually, because I didn't have it on this last test. It will be on this next one, because we have to actually look at pictures now and measure angles. Angle measures of corners. But again, every triangle has 2 names. It's one name comes from the side lengths, one name comes from the angles. Now, what we're going to do now is go through what those names could be. And I'm going to try to break them up into those 2 categories. There's 7 words. One of the categories obviously has 4 words. I don't think I have the 4th word on the slide. I'll just write it on the board so you have it. Okay? Okay, so let's go through the main terms here. So for a triangle, if we're going to call it by its side length, so if I'm going to actually put a ruler down and measure its walls, let's talk about its side lengths. Number one, if I want to call it when I measure all the walls and all the walls somehow turn out to be different from each other. Scaling. Scaling triangle is when I look at a picture of a triangle. This is the same picture I used earlier. I just took A, B, and C off of it. When I look at all the walls, they're all different in length, right? When I measure them. So all different. So this is the markings they might use in your book. Those 3 hash marks. The hash marks don't tell me anything other than the 3 walls are different. That's all the hash marks tell me. I can't tell you which one's longer other than just common sense looking at the picture. The hash marks don't tell me that. Like a 1 wall doesn't need to be the longest wall. The 3rd wall doesn't need to be the longest. They're just random markings. They just tell me the walls are different. So maybe this wall's 20 and this one's 22 and that one's 18. I have no idea. They're just different in length. The second one, I heard somebody say it. Isosceles. Isosceles, they have to have a marking for isosceles because 2 walls match. They have to have it marked. So again, scalene, all 3 sides are different. All 3 edges are different. Or what the book refers to as all 3 edges are non-congruent, they're not equal. But on an isosceles, 2 walls match. The 3rd wall, I could care less about. The 3rd wall could be smaller, it could be bigger, don't care. Just 2 walls match in length. Now, when I write isosceles, I typically spell it wrong. I always forget the second S. And most people will mix these 2 words up. They always get them mixed around. Scaling is different, isosceles match. Next one.
Right.
Nope.
No.
Equilateral. Equilateral. Literally is the word equal in laterals. Lateral is that Latin word for sides or edges. Equal edges, equal sides. Right? All 3 walls are the same. Now, I know, I even had a question in the last class me asked, like, isn't equilateral technically isosceles? Yeah, it's isosceles, 2 walls match, but it also has the 3rd wall, the other wall matches as well. So that's what makes it a new term. Again, this is all based on if I were to measure the walls. So if I went back to that first picture, I have to pick one of these 3 words for it. Every triangle. So if you drew a random triangle in your picture, I have to call it one of these 3 automatically. Does that make sense? Why it has a bunch of terms. Okay, now let's call it by its angles now. So if I'm going to name a polygon by its angles, this has 4 terms. Now I think I only have 3 words on the slide. There's a 4th. I'll put it on the board here in a minute. If you're going to classify it, if all the angles are less than 90 degrees, what type of angle is that? Acute. It is called an acute triangle. In fact, there's the first picture I showed you earlier. That's the ABC triangle earlier without ABC printed on it. All 3 angles, if I were to put my protractor up there, they are clearly less than 90 degrees each. That's what makes it an acute triangle. All 3 angles are less than 90. So you can measure. Put your protractor, measure each angle separately. Second one, if you have a right angle in there, you measure an angle and it's right, it's a perpendicular, it's orthogonal, it's flush, square. Well, guess what? It's called a right triangle. Duh. It's got a right angle in it. Right triangles. Now, here's the thing. Where we're at currently, if they're marked in a plane, a flat surface, you can only have 1 right angle. Only 1. The other 2 have to be small. You can see these 2 are acute. When we go away from planes, we go to 3-dimensional pictures, all the rules are off. But when we're on flat surfaces like my marker board, only 1 right angle. I'll explain that concept later. You probably think I'm crazy. You'll all see it later when I show you. When we get to, I think it's chapter 3 or 4, when we start talking about triangles and all the properties about them, that's literally a property we have to discuss. If there's 1 right angle if you're on a 2-dimensional picture. Okay, now, if I had an angle that is clearly larger than 90 degrees, what type of angle is that? Obtuse. You have an obtuse triangle. One angle is larger than 90. Now, how do you know that? Common sense, just look at the picture. You can see that I'm past an L shape. Now, here's an L shape. I clearly went past that. So it's definitely obtuse. The problem is when you go to obtuse and they switch the picture up and they draw the picture differently like this. Now it's harder to tell. For some reason, the human brain has a real struggle with seeing what type of angle that is when it's drawn on the top. Because it kind of looks like a right angle. Kind of does. It's the same picture. You're to orient it, it is the same picture. It's really weird the human brain can't function that way. It's an optical illusion. The brain can be tricked. So, it's one of those weird things you just can't wrap your head around. So obtuse, you really have to like turn the picture and see it that is drawn that way. In your online textbook, you guys have the luxury of like turning the pictures on your Chromebook. I think there's like an orientation button, it'll like turn the page so you can look at pictures differently. Or if you have the physical book, just literally turn the book so you can see that in a different light. That will help you out. Now, there's one other word that we need to have. The fourth word for a triangle. It's when all the angles are the same angle. That can't be obtuse because obviously there can only be one obtuse. There can only be one right. But when you have acute, you could have where all three angles are the same. There is that opportunity where that could happen. Okay, the book will mark it like this, or it might put little hash marks in here like that. All three angles are the same. Well, that is called equiangular. I typically spell that word wrong a lot, so I always put the I in there. Equiangular. All the angles are equal. Now we're going to do a little like kind of activity on Monday to get you kind of like familiar with some of these words, but anytime you look at a picture of a triangle, you have to give it one of these words as well. So if I went back to that first picture today, I could call it scalene because all the walls are different, and I could call it acute because all the angles were less than 90, because this is the first picture, by the way. I just had ABC written out. So all three sides were different, and all the angles were less than 90. So it's acute scalene triangle. All right, questions at all about the types of triangles? We've got all the words written down. They're fair game for vocab. This chapter will have a lot of vocab because we're talking about all the shapes. So you gotta be kind of cautious of that. Okay. Last slide. No joke, last slide.
Promise?
Promise, last slide. Okay, what we're going to talk about on Monday, other than the triangles, because we're going to do that activity, we have to talk about the quad. Quad literally means four, right? Most people think of like a quadrilateral as a square or rectangle. There's other shapes. There's like 7 different ones. In fact, what most people don't know is like a quad doesn't have to be a rectangle. It doesn't have to be a square. Like this picture is not any of them. All these walls are different lengths because I made them that way, and all the angles in the corners are all different. So a quad is just a random four-sided figure. It could be a specific type of quad if all the properties work out perfectly. It's not like a triangle where you have to give it 2 names. Quads could just be a quad. It doesn't have to be a separate category. Now there's 3 specials that it could be, right? Because if you have 4 walls and 4 vertices, right? But it could be a special category, right? It could be. It doesn't have to. It's not like a triangle where it has to be 2 words. A quad could be a parallelogram. It could be a trapezoid. It could be a kite. Those are 3 very different words. In fact, I'm betting on most people didn't even know those words walking in. That those are different types of quads. Okay, we'll have to discuss those on Monday. Make sense? We're done for today. That's your last slide.